Hi there. Before we work on the actual problems that you've asked about, I need to make sure that a couple of skills are okay. Let's suppose that we have a problem. This will be our first one to look at. And you have a fraction and you're multiplying it by a whole number, but you notice that the denominator of the fraction divides into the whole number. Then what if you do that? 2 goes into 2 one time, 2 goes into 8 4 times. You're left with 4. 1 times 4 is 4. 1 times 1 is 1. We don't leave whole numbers over 1, so we get 4. Let's look at the next one. Once again, if you have a fraction multiplied by a whole number, you check to see if the denominator divides into the whole number. The answer is yes. 3 goes into itself once, 3 goes into 12 4 times. Multiply the tops, 2 times 4 is 8. Multiply the bottoms, which is 1. 8 over 1 is 8. Last of these examples, this 30 is really over 1, so this you check to see. 5 goes into itself once, 5 goes into 36 times. 4 times 6 is 24. 1 times 1 is 1, and that's 24. You're going to use that skill. Now, another skill is least common denominator. And I think I've referred you to Khan Academy, but let's just take a look. If there are many cases where you need what's called a least common denominator or an LCD. One of the cases is when you add two fractions. Suppose you have 4/5 plus 3/8. You can only add fractions when the denominators are the same, and those are not the same. So you're looking for something that 5 divides into and 8 divides into. Sometimes you can simply multiply 5 times 8 and you get 40, and so that's the common denominator. I'm not going to do any more with that because we're not adding fractions, but that is one case where you need a common denominator. If you had 1/3 plus 4/9, you would have to have a common denominator. Now, in this case, you don't need to multiply 3 times 9. If you did, you'd have 3 times 9 is 27, and that is a common denominator because both 3 and 9 go into it, but it's not the least, smallest common denominator. So in this case, you check the bigger denominator. 9, of course, goes into itself. Does 3 go into 9? The answer is yes. That means that the LCD is merely the big denominator of 9. So you would put 9 and you would put 9. Once again, we're not adding fractions, but that's what most people think of when they talk about common denominators. We're going to use it differently. Finally, what if you had 3/8 plus 1/12 and you wanted a common denominator? Now this one I'm going to do even different than I did the last two. I'm not going to just multiply 8 times 12. I'm going to go to the big one, which is 12. Does 8 go into 12? No. So I look at multiples. Remember, least common denominator, this is something that both of them go into. So I start with 12 and it doesn't work. The next multiple of 12, 2 times 12, is 24. Does 24 work? Well, by work, I mean, does 8 go into 24? Does 12 go into 24? And the answer is yes. So I just did 3 problems by 3 completely different techniques. I multiplied the 2 denominators in the first one to get 40. In the next one, I used the big denominator. And in the last one, I looked at multiples of the big denominator. So I know that can be a little confusing. When this is taught for the very first time, it is taught by using what are called prime factors. So I'm going to go over that. I don't know if you're going to use it, but let's look at each one of these. The first one, I had denominators of 5 and 8. Well, 5 is a prime number. There's no factors of 5 other than 1 and 5. So it is a prime number. 8 is not a prime number because I can break it into 2 times 4. 2 is a prime number because there's no way to get 2 except 1 times 2, but 4 is not because I can break it into 2 times 2. So this one is a prime. The least common denominator is one of every different kind of factor, and the only kinds of factors I have are 2's and 5's, but I need the highest power. Because this had a 1, 2, 3 of those 2's, it's 2 to the third. If you multiply 2 times 2 times 2 times 5, you will get 40. Let's look at the other one. We had 3 and we had 9. 3 is a prime number because there's no way to get 3 except 3 times 1. 9 is not prime. It can be broken into 3 times 3, and those are primes. The LCD is one of every different kind of factor. Well, the only factor I have is 3, but I need the highest power. This has a single 3, but this one has 3 to the second power. So I get 3 to the second power, which is 9. The last one I did had an 8 and a 12. Sorry, that's very messy. All right, prime factorization of 8. Factor it any way except 8 times 1. All right, 2 times 4. 2 is a prime because I can't go any further. 4 is 2 times 2. If I wanted to, I could say that's 2 to the third power. 12. I'm going to call it 2 times 6. That's a prime. 6 is not because it's 2 times 3. Prime, prime. This is 2 to the second times 3. How do I find the LCD? I have 2's and I have 3's. I take the highest power, which is 2 to the third, rather than 2 to the second. What does that give me? 24. Doing this prime factorization is the formal, original way to find a least common denominator. But honestly, I use some of these other methods sometimes. Okay, I'm going to go get one of your questions, and then I'll work through it. All right, the first one you sent me looked like this. 7/9 x equals 3/18. The first thing you want to do is just take a look at the denominators. I have 9 and 18. This is a case where 18 is the big one, 9 goes into 18, so the LCD is 18. I could do it the long way. 9 is 3 times 3, or 3 squared, those are primes. 18 is 2 times 9, that's a prime. 3 times 3, those are primes, so it's 2 times 3 squared. For the LCD, I need a 2, and I need a 3. I need the high power, which is 2, and that is 18. So it was a whole lot quicker to do it this way, but this is the formal way. Back to our problem. When the LCD is 18, in red, I'm going to multiply the left side by 18, and I'm going to multiply the right side by 18. That 18 is really over 1. Do you remember the very first thing that I started with in this video is how do you multiply a fraction by a whole number if the denominator divides into it? Well, since 18 is the LCD, the little denominators have to divide into it. 9 goes into itself once, 9 goes into 18 2 times, 2 times 7 is 14, and there is an x, so it's 14x. On the right-hand side, 18 goes into 18 once. 18 goes into 18 once. That leaves you with 3. Now I know this is kind of an ugly thing, but we need to divide both sides by the coefficient, which is 14. X is equal to, unfortunately, I cannot divide 14 into 3. I cannot reduce it. My answer is a very unpleasant 3/14. Let's look at another one. All right, here's the second one that you sent me. In this one, I have 3 terms. I have an x over 5, I have a 3, I have an equal sign, and then a 16 over 5. I only look at, to start with, the denominators. Since the only denominator is 5, the least common denominator is 5. Both of these 5s with yellow will divide into the least common denominator. What do? I multiply every term by it. 5 times x over 5 plus 5 times 3 equal sign 5 times 16 over 5. Even if it's not a fraction, because it's an equation and you have whatever you do to the left, you have to do to the right, you have to multiply every term. So I have 1, 2, 3 little problems to look at. The first one, this 5 goes in here once, it goes into the red 5 one time, and I'm left with x plus 5 times 3 is simply 15. Equal sign. In the right hand side, I have 5 goes into 5 once, 5 goes into 5 once, and I'm left with 16. You get an equation to solve that does not have fractions anymore. The LCD served the purpose of causing those denominators to divide into it, and they were gone. So now I will subtract 15 from both sides, and I have x is equal to 1. I'm just going to do a couple more. I'm not going to do actually all 9 of them, but I want to make sure that this is making some sense. So I'm going to go get another question. All right, the next one, I've got an equation with a fraction, so I need to get rid of the denominators. I look at the denominators. Well, I only have a denominator of 3, so the LCD is 3. But I will need to multiply all terms by the 3. I'm going to sneak it in this time. I have 3 times the y over 3. I have 3 times the y, and I have 3 times the 6. Every term gets multiplied, even if it's not a fraction. But when it is a fraction, the denominator of 3 goes into itself once, and it goes into 3 once, and you're left with y. The next one, not a fraction, just multiply. That's 3y. Equal sign. 6 times 3 is 18. I have like terms. I subtract. There's an invisible 1 there, so I end up with negative 2y is 18. Divide by negative 2. And y is positive divided by negative gives me negative 9. I'm going to look for one more problem. All right, in this one, look at just the denominators. What will 3 go into and 2 will go into? The LCD, those are both prime numbers. Take one of each of them. It's 2 times 3, which is 6. The LCD is 6. So I'm going to multiply 6 times x over 3 plus 6 times 4 equals 6 times x over 2 plus 6 times 6. On this problem, I have 1, 2, 3, 4 products to look at. The first one, the 3 is a fraction. It's a denominator of a fraction. 3 goes into itself once. 3 goes into 6 2 times. I have 2 times x, or 2x, left over, plus. The second product, it's just 6 times 4 for 24, equals. On the right-hand side, here's the denominator. 2 goes into itself once. 2 goes into 6 3 times. I have 3 times x, or 3x. Last one, 6 times 6 is 36. Now I have an equation with no fractions in it. I do have variables on both sides. I choose to subtract 2x from both sides. I'm not dividing, I'm subtracting. Let me get rid of that. That's gone. I have 24 is equal, 3x minus 2x is implied 1x plus 36. Subtract 36 from both sides, and I get negative 12 is equal to x. All right, I hope that this video helped you understand all the different skills that you needed. Write me back if you have other questions.